Hi guys, we are going to start talking about parent functions a little bit. We're going to go a little bit away from solving equations and simplifying. We are going to go ahead and talk about these parent functions. These are the basic parent functions that we're going to discuss this whole year. Linear, quadratic, square root, exponential, cubic, cube root, absolute value. All right, these are the main ones that we're going to be discussing. And some of these you should already know, like the parent linear. What is the parent linear? Y is equal to x. That is our parent linear function. And one characteristic is that it looks like a line. It has a slope of 1. We don't have to put all these points, but I'm just pointing out what we should already kind of know as a 1-1 slope. And each of those points that I drew are things that we should already know about, right? Now, when we make a table, okay, this is the parent table that I usually remember. Mr. Bandu, how in the heck do you remember this? Well, in fact, I've been teaching math for a while, so of course I remember. But if you don't remember, it's as easy as understanding that when you make a table, you're the author, right? So let's pretend that let's erase these three, right? Let's say I want to find out what's the value of y when x is 0. I'm gonna go to the function. Sorry, I'm gonna go to the function and replace x with a 0. What does it say now? Y is equal to 0. Ta-da! It's super simple. How about 1? If x is 1, or y, we replace the x with a 1. Y is equal to 1. There we go. That's my y value. What if x is equal to 2? Y is 2. Simple like that. Right? We will talk about domain and range a little bit later. Right now, we're just going to get the main function. The parent quadratic function, if you all remember, it's y is equal to what? X squared. This is the parent function. Now, just like we did before, right? We choose values. If you want to make a table, you want to make your own table, and you don't remember how the graph looks, you could always plug in numbers into the equation. So let's go and do that. I'm going to put 0 right in the middle. If I want to find out what y is, I'm going to replace x with 0. Well, what's 0 squared? 0. Right? And when we make a table, we get to choose what number I want. Now, I could choose 1. I could choose 100. I could choose 11,100. Right? Your options. But the best thing to do is to keep it simple, right? We're not going to be having calculators in Algebra 2. So it's best to use small numbers, stuff that we're comfortable with. So let's go ahead and x is 1. That means I'm going to replace x with 1. Right? And what's 1 squared? 1. Now I'm going to replace x with what? I'll just replace it with, what's the next easiest number? 2. What's 2 squared? Well, 2 squared means 2 times 2. That's 4. Next, well, let's go backwards. Negative 1. What if x is negative 1? I'm going to replace x with a negative 1. Right? Because our parent function was y is equal to x squared. If you're like wondering, why is he just putting numbers there? I am replacing the x with whatever number I want. Now, what's negative 1 squared? I hope that you said 1. If you said negative 1, you are wrong. Remember, negative 1 squared means negative 1 times negative 1. A negative times a negative is a positive. Now, let's go ahead and do replace the x with a negative 2. Negative 2 squared? Well, negative 2 squared is positive 4. And voila, we have our table there. Right? So if you have your table, you should be able to graph the quadratic function, how it looks. Right? I'm going to graph the points negative 2, 4. Here's -1, -2, then 4 up, 1, 2, 3, 4. That is where my point goes. Next one, -1, and then 1 up. That is where my point goes. 0, 0 right here, 1, 1, 2, 4. As you remember, something very important about quadratics is that they're symmetrical, right? They are symmetrical. The vertex, where's the vertex? If you don't remember what the vertex is that point right here. Right there. That is my vertex. That vertex for the parent function starts at 0, 0. In this case, the x-intercept is 0 as well. My right is a point. The y-intercept is 0. Boom. We'll talk about domain and range in just a bit. Square root function. Parent square root function is y is equal to square root of x, right? And we choose numbers, right? Now, I'm the teacher. I already have experience with this function. I kind of know what it does and how it looks and what it does. Now, one thing you should remember is inside, let's do a different color. Inside the square root cannot be negative. Yeah. We have an issue inside the square root if it's negative. So for instance, I'm gonna write the parent function here once again, just so that we see what we're replacing. Let me rewrite it in all the same color. Right? And I'm replacing the x with whatever value I want. Now, here's the deal. I'm not gonna plug in -1 here. I'm not gonna replace the x with a -1. I'm gonna say -1. I can't do that because if I do, let's do that. If I plug in -1, right? Can I find the square root of a negative number? Can I do the square root of -1? No, that's not possible. So guess what? This is undefined. That means that we have no point whenever x is -1. So if we were to go ahead and try to graph a point at -1, we would not see a point here, right? So this is -1. There would not be a point anywhere along here. So what do? Well, let's choose values that are positive, or we start with 0, actually. Square root of 0. We know the square root of 0 is 0. Next number. What's the next number you think would be a good number? 1? Let's try it. Square root of 1. Do we know square root of 1? Yeah, square root of 1 is 1. Awesome. Let's erase that. Next number. What do you think? 2? Don't write this down yet, though, okay? Square root of 2. Do we know square root of 2? No. We do not know the square root of 2, so guess what? We might not want to use the number 2 because the square root of 2 is like 1.47 something. It's not going to stop. So we want to choose something that we actually know the square root of. And here's a hint. For square roots, you need perfect squares. Okay? Like 4. We know the square root of 4 is what? 2. What's the next perfect square? If you did not know, you can look in the back of your bookmarks, and there's the perfect square table and perfect cube table as well, in case you need them. And you'll notice that the next one is 9. Square root of 9 is 3. That is our table. All right. So our parent function is y is equal to square root of x. And then we could find more points if we go along and do that. Now, let's graph 0, 0, 1, 1, 4, 2, 9, 3. Now, a very important point for this is our end point. This point here, when it starts it, that's our end point. Funny because that's where it starts, huh? But if we have a point there, we have an arrow here, boom. End point is 0, 0. That's our x-intercept as well, and that's our y-intercept. Next one, exponential function. Cool. So our exponential function works in this manner. Y is equal to b to the power of x. Now, there's a lot of parent exponential functions depending on the base, the b. Excuse me. The base could be any number. So what we're going to do, we're going to focus on one of the bases. We're going to focus on y is equal to 2 to the power of x, okay? And we're going to work this thing out. Cool. So just like we did before, okay? Exponentials, we're going to go ahead and fill out our table. Now, I'm going to put the values so it can be a little faster, right? We'll put negative 2, negative 1, 0, 1, 2. And those are going to be my values, okay? Now, exponentials have something called an asymptote. Very important, okay? I'm going to color this asymptote. I'm going to do the color orange. And the asymptote for the parent function is usually goes through our x-axis. And what it does is that the points get close and close to this asymptote, but it does not touch. The asymptotes help us with end behavior. It tells us what happens towards the end. Okay? But for us right now, we're going to use it as a, hey, it doesn't touch this. Okay? So when we look at this, we're going to graph this. I'm going to plug in all these values, and I'm going to do it a little bit faster just so that we understand what we're doing, right? So just so we could go a little bit faster in the video. What I'm basically going to do, I'm going to say 2 to the power, say 2, it's not worrying, 2, not writing there either. What's wrong with my pencil? I don't know. Down here. Whoa. Oh, I know what's wrong. Oh, silly me. Okay. So, I'm going to do 2 to the power of negative 2, 2 to the power of negative 1, 2 to the power of 0, 2 to the power of 1, and then 2 to the power of 2. You with me? Remember, 2 to the power of negative 2, we have a negative power. We get rid of negative powers by rewriting it like this. Take it down, make it a fraction. No longer do we have a negative number as a power. That's one thing we try to do with all exponentials. So this one would be 1 over 2 to the power of 1. Cool. So what's 1 over 2 to the power of 2? It's 1/4. 1 over 2 to the power of 1, 1/2. 2 to the power of 0, remember, anything to the power of 0 is equal to 1. 2 to the power of 1 is 2, and 2 to the power of 2 is what? 4. The asymptote, like I mentioned before, it's on the x-axis, so we're going to say y is equal to 0. That's how we get it. Remember, y equal to a number, we get a horizontal line. And if we graph these points, I'm going to do my best to graph somewhat legit. 0, 1, I could graph that one real easily. 1, 2, 2, 4. Now, negative 1 to 1/2, negative 1 to the left half, right there. Negative 2 is smaller. So, I'm going to draw this, okay? Now, keep in mind, my line should be going through here, but it's not going to touch the asymptote. It looks like it's touching. It should not be touching. We're getting real close, but not touching. Remember, does not touch the asymptote. Okay. Now, cubic, cube root, and absolute value. I'm going to do this real fast. Same idea, okay? Cubic is y is equal to x cubed. Cube root, y is equal to the cube root of x. Absolute value, y is equal to the absolute value of x. Okay? Now, let's go ahead and fill this out. Let's do this fast and efficient. Y is equal to x cubed. I'm going to use these numbers, just like I did the other ones, okay? You plug in it, replace the x, you get that value. So negative 2 to the power of 3 would be negative 8. Negative 1 to the power of 3 would be negative 1. 0 to the power of 3 would be 0. 1 to the power of 3 would be 1. 2 to the power of 3 would be 8. Okay? That would be my answer. So 0, 0, 1, 1, 2, 8, and then negative 1, 1, negative 2, 8. And my line will look something like this. Now, this one actually doesn't have an end point, it has a turning point. And that's right here. Point of inflection, I should say. 0, 0. Now our cube root, I don't know if you guys knew, but these cubic and cube root, they're the inverses of each other. What's cool about inverses, and we're going to talk more about this, is that their graphs, their tables flip. And if you know this, well, that makes it very easy to graph. Because we have the table. It looks something like that. Our turning point is the same as here. It's 0, 0. Right? That's our x-intercept. That's our y-intercept. Or absolute value. Okay? Absolute value. It's always positive. I want you to remember this as well. It equals what? Distance. So, it's always positive equals what? Distance. So, when we look at this, right, I'm going to choose these values. Right, and I'm going to replace the x with 0. Let me start with that one. The absolute value of 0 is 0. The absolute value of 1, well, that's 1. The absolute value of 2 is 2. Now, when it's positive, it doesn't matter whatever we put in there. But when it's negative, like this, absolute value of negative 1, we're actually measuring the distance from 0 to negative 1. How far does it go from 0 to negative 1? It goes 1 unit. That's why we say absolute value is always positive, because it measures distance. Is there such thing as we went a negative distance? No. I say I ran negative 300 feet. No, that means you just did not run, right? We talk about direction instead of negative, right? I ran 3 miles east, ran 3 miles west, whatever the case is, right? So when we do absolute, what's the absolute value of negative 2? We say positive 2. And that's how you measure absolute. This one looks like a V. Right. Voila. The vertex, just like the quadratic, That's our 0, 0. That's our vertex. That's a very important point. That's our x-intercept, and that's our y-intercept. And this summarizes our parent functions that we're going to be talking about.